So now, how can we represent sets using a diagram? So generally we call it as the Venn diagram. So what we do is we simply draw a box which we consider as the universal. That means each and every element is there inside this box. Now let's say I have two sets, A and B, and now I need to represent it in this Venn diagram. So what I do is I simply write down a circle with A, B. I hope you all have done all these things during a school time as well. So this is not something new for operation of sets that you are studying. So again, we consider some portion that might be in conjunction with A and B both, and some portion is going to be simply A alone and B alone. Now let's say if I was to represent a Venn diagram of three sets, it would simply be in this way. So a Venn diagram is basically a visual representation of sets showing relationship between different sets using overlapping circles or shapes. So generally we use circles to show that. Now let's say this is my set C. This is going to be my universal. That means all elements that do not belong to A, do not belong to B, do not belong to C, but are in our topic of discussion, they would belong to the universal portion. Now again, different operations, talking about union. A union of any two sets A and B contains all elements of A and B. That means if I was to represent this in a set builder form, how can I write it down? I can say X, where X belongs to A or X belongs to B. So X should can belong to either A or B. That means either of these two cases can be taken. So here, if I was to shade the portion in my Venn diagram, that means this entire portion, the one that you can see has been shaded in yellow as well, this entire portion becomes my A union B. Now there are a few properties again of union that you need to keep in mind. Let's say if I have A union B, this would be equal to B union A. The number of elements, the elements would of course be same. Now let's say if I do A union phi, I have just one set with me and I union it with phi, so it is going to be A. Now let's say if I union A with universal, so what am I going to get? Universal. With universe and A, everything is going to get included, so universal comes as my answer. And let's say if I take the union of a set with itself, it is going to come out to be the set itself. So these are few properties that you need to keep in mind. Now these properties are going to be more or less similar. According to your logic, you can definitely write down for all other operations as well. For example, be it intersection, difference, complement, or any other things. Now for intersection, A and B contains only the elements which are in both sets. So if in Venn diagram we see this is the portion shaded, that means this is the portion that comes in A as well as B. So if I was to represent this in a set builder form, this would become X, where X belongs to A and X belongs to B. Initially in union we had used the word or, here we are using the word and, so keep this in mind. Now again the same properties, if I do intersection of A with A, we are going to get A. If I do intersection of A with universe, what am I going to get? We are taking only the common terms with universe and A, so we get A. If I do A intersection phi, we are going to get phi. What are the other properties? Now again, if I do A intersection B, this would be equal to B intersection A. Be it in any other way, be it unordered, the elements are going to be same, right? So that is what matters. Now talking about difference, A minus B. This means the elements which are only in A, the ones which are in B are going to be eliminated. So all the terms which are in their intersection as well, those are also going to be eliminated. So in this diagram also you can see this is the shaded portion. That means this is my A minus B diagram. Now let's say if I was to reverse this and I was to ask you what would be your B minus A. Again, B minus A would simply be two sets where this is your B, this is your A. B minus A would simply be this portion. So we are considering the elements only in set A which are not common to set B as well. So keep this thing in mind. Now let's say if there is another operation in difference that you need to keep in mind, which is known as the symmetric difference. We call this as the symmetric difference. Where we have two sets, again A and B. We generally represent symmetric difference by this A triangle B. What does this mean? This means A minus B union B minus A. So if you look at this carefully, if I do the union of A minus B and B minus A, what am I going to get? This would be my portion that is going to be shaded. Apart from the portion which is in intersection, all the other portion would be shaded. So this becomes my symmetric difference. Now talking about complement. Complement means all other elements apart from my set A. So you can see complement is generally represented by A with a superscript C. This can also be written as A bar or A dash. So all these mean the same thing. Keep this in mind. It is basically union or universal minus A. So let's say if I union of A complement with A, what am I going to get? It would simply be my universal. And let's say if I intersection of A and A complement, I would get phi, because there would be nothing in common between them. Now let's say if I have two sets and if I find out certain types of functions or operations with them, so A union B complement would be A complement intersection B complement. The sign which used to be union, it changes, and for intersection as well, this would become A complement union B complement. So keep these two properties in mind as well. Now if I was to tell you, let's say you have universal complement, what is it going to be? Phi. And let's say if you have phi complement, what is it going to be? Universal. So this is how generally complements are represented. So now first let's look at a very basic question again. You're going to be saying that why are we doing such basic questions? But after that we'll look into the more depth JEE mains level questions. So first, before that, again, whatever we did in this union intersection, if I was to represent them in let's say an equation form, what I can do is I can represent the number of elements. So here what I am doing is number of elements in A union B would be equal to NA plus NB minus NA intersection B. Now you must be thinking, why are we subtracting this? So let's say if this is my set A, this is my set B. First, when I add NA, this portion gets added. Now when I'm adding NB, again this portion gets added. That means you can see that the intersection portion is getting added twice. That is why we subtract it once. Similarly, for three sets also, you can draw the Venn diagram and understand how we are coming up to this function. Now, generally, whenever questions are asked, you can either solve it by using these equations, or you can use your Venn diagram. And Venn diagram is considered to be the most easiest and the most fastest way of solving questions of sets. So I would recommend you to use that only. Distributive laws, again, A union B intersection C, you can simply distribute them at different brackets. So A union B intersection A union C. Same thing goes for intersection as well. Now let's look at this question. So you have been given three sets: A 1 2 3 4 5 6, B 3 4 7 8, C 5 6 9 10. Now they've told us find out the value of elements in A union B union C. Again, if I write down A union B in modulus sign, so this is not modulus, keep this in mind. This basically means I'm wanting you to find out number of elements in A union B. So this is another way of representing your cardinal number, minus A intersection B intersection C. So first what we'll do is, let us find out our A union B union C. What is the set going to be in A union B union C? First of all, I'll have all the elements of set A. Then what are the other elements in set B? 3 4 have already been included, 7 and 8. Those two are new elements. Then we look for C. 5 6 have already been included, 9 10. So this is my A union B union C, which is equals to 10. So 10 is basically my cardinal number for this set. Now let me do for A intersection B intersection C. So first of all, what I'll do is, I'll first find out A intersection B, and then I'll intersect it with C as well. So first of all, what is my A intersection B going to be? 1 2 3 4 5 6 3 4 7 8. So what are the common terms? 3 and 4. Now if I do A intersection B intersection C, now I intersect C set with this one, 3 and 4. So again, there are no elements, so this becomes 5. That means there are 0 elements in this set. So simply, if I was to find out the value of this would become 10 minus 0. 10 is my answer. So option A becomes my answer. Now let's look at a proper JEE level question. This was again a question that was asked in previous year JEE mains. I would recommend you all to first pause the video, try to solve the question by yourself, and then look at the entire solution. So what have they given us? They've given us two sets, S and T, and we need to find out the number of elements which are common in both these sets. So first of all, by just looking at these sets, you can see that the T set, it is in a quadratic format. That means it is easier for us to solve the quadratic one. So let us first find out the elements in T. And you must remember that X belongs to Z. This Z means here integers. So T, how can I write it down? So firstly for T, what I have to do is I need to find out the solution of this quadratic equation. So it is x square minus 7 mod x plus 9 less than equals to 0. Now since here I have x square and modulus of x square is equals to x square, so I can represent this by modulus x. Now this mod x, I hope you all know what its job is. Its job is to make all the negative values inside it positive. So sorry, it can be greater than equal to 0 as well. And one more thing, just a reminder, I hope you all know what this means. Let's say if I have A to B, that means I'm considering each and every value. Let's say if this is my number line, here I have A, here I have B. That means I'm considering each and every element from B to A. From B to A. And I'm including A and B as well here. Now when we talk about open brackets, this is round brackets are known as open brackets. That means I'm considering every element from A to B. However, I'm not considering A and I'm not considering B. So they are generally represented by an open holes. So I hope you all know these things. These are just a reminder of the basic concepts that you must have studied. So here what we are going to do is, first I'll assume my mod x to be t. If my mod x is t, what will happen is this would simply become a quadratic equation. Now again, solving quadratic equations are something you've already done. So what can I say about t? T can be equal to minus b plus minus root under b square 49 minus 4ac. So this becomes 9 4s are 36 upon 2a. So from here this would become 7 plus minus root under, this would become 13 by 2. So since it is plus minus, that means, and we have an inequality here. So keep in mind, we have an inequality here. It is not equal to. That means my t would belong to a set which is going to be a closed set, because there is an equal to sign here as well. So it would be from 7 minus root 13 by 2 up till 7 plus root 13 by 2. So this is going to be the set. Again, finding out the range of such sets you've already done in your class 11th. So this is not a very new thing that I've just written down. So this is the set that I've gotten for t. So what is my t basically? My modulus x belongs from 7 minus root 13 by 2 comma 7 plus root 13 by 2. Now they've told us in this set that x always belongs to integers. So I can find out what are going to be the integers in this range. So if I was to first find out the approximate value of this, the approximate value, what is it going to be? Root 13. Root 13 is somewhat, it is going to be greater than 3 and less than 4. So 3 point something. And if I subtract 7 minus 3 point something, what am I going to get? Point something, and then that would become 4. So 3 point something again. So I would have 3 point something by 2. It would make it 1 point something. That means this is approximately equal to somewhat a value which is greater than 1. So this value basically is greater than 1. So I need to keep this thing in mind. Now for 7 plus root 13 by 2, I'll do the same. So what is my root 13 going to be? It is going to be 3 point something plus 7, 10 point something divided by 2, 5 point something. So this is a value which is less than 6. So from here, that means my range is basically a value which is greater than 1 and less than 6. So what are the integers in this set that are going to be? 2, 3, 4 and 5. 6 and 1 are not included because the value is going to be greater than 1 point something and it is going to be less than 5 point something. So from there we get this set. So my modulus x basically belongs to this. This is my t set. So I've gotten my t set now. Now let me talk about my s set. Now again, it is going to be very difficult for me to solve for the s set, right? They've given us a very difficult equation which has modulus in it and a lot of things. Now first of all, what I can do is, if I replace this x, modulus x, into x, what would my t set simply become? It would become plus minus 2 comma plus minus 3 comma plus minus 4 comma plus minus 5. So this is basically my x in my t set. However, this is not necessary for me, because if I look at my s set, in my s set they've given us an equation which has modulus x in it. So I can directly put the values of modulus x rather than putting the values of x, right? So the equation that they've given us, it is x plus 3 modulus minus 1 upon modulus x minus 2 greater than equal to 0. And then what is the condition that they've applied? They've applied this condition that it belongs from minus 6 to 3, and minus 2 and 2 are not included in this set. So Now what I'll do is, since we needed to find out the intersection, so what I'll do is I'll one by one check for modulus x whether all these 4 values satisfy this equation or not. So the values that would satisfy, that would become our answer. So what I'll do is, first I'll check for modulus x is equals to 2. Again, if I put modulus x is equals to 2, this is not going to be satisfied because I would have a 0 in below. So it would come out to be infinity or undefined. And each and everything should be defined. I mean, you need to have a finite value, then only you can say that it is a possible value. So 2 gets rejected. Now let's say if I take modulus x to be 3, what would it become? It would become modulus x plus 3 greater than equal to, this would simply become 1 below. So this would become greater than 1. So is my x plus 3 going to be greater than 1? So what are the values of x that are possible first of all? So if modulus x is equals to 3, that means I can have my x as plus minus 3. So if I put x as 3 plus 3, it is going to be greater than 0. So plus 3 is satisfied. If I take x as minus 3, this would make it 0. So minus 3 has to be rejected. So minus 3 gets rejected from here. So I cannot take minus 3. Now 3, I'll check whether it is included in this range or not. Yes, 3 is included. So 3 becomes one of my answer. That means in my S set, one of the elements is 3. Now I'll check for 4 as well. Now what I'll do, I'll check for mod x is equals to 4. If my mod x is equals to 4, below I'll have 2. Again, that 2 does not matter. It is going to get cross multiplied. I would again be left with this condition only, where I can say x is equals to plus minus 4. If I put both these values, only plus 4 would satisfy. And if I put plus 4, this would become 7. And 7 plus 4, basically, is it lying in this range? So if I put, modulus x as 4. So modulus x would be equal to 4. That means my x can be plus minus 4. So if I put plus 4 here, it is going to come out to be 7. However, plus 4 is not cannot be taken because plus 4 is not included in this set, right? Now if I take minus 4 here, if x is minus 4, minus 4 plus 3, this would make it 1 minus 1. And since it is under modulus, it would become 1. So minus 4 basically satisfies this equation. And minus 4 lies in my range as well. So another value that it becomes common is 4. Because I'm taking only the common elements of modulus. Or let's say if it is not very applicable to you, so I'll just take minus 4 here. Now what I'll do is I'll check for modulus x is equal to 5 as well. So x can be plus minus 5. So if I put plus minus 5 in this equation, so if I put plus 5, again it satisfies. However, plus 5 is not included in this set, right? So plus 5 would get rejected. If I take minus 5 plus 3 would give us minus 2. Modulus would make it 2. 2 greater than equal to 1. Yes, it is satisfied. So is minus 5 in our set? It is from minus 6 to 3. So minus 5 is in our set. So minus 5 also becomes our answer. So basically we are going to have 3 elements in sets S. Now what are the common elements from T and S? Because we need to find out intersection of S intersection T. So what are the common elements going to be? 3, minus 4, minus 5. So these become my answer. What was asked to us in the question? The number of elements in S intersections T. So this becomes 3. So n of S intersection T, that was what we had to find out. This becomes 3. So this is how generally you must solve questions. First, identify which set is easier for you to solve that one out, and then see, since they had asked us to find out the intersection, what we did was we checked for each and every element of T in S if they are satisfying or not. The ones which satisfied became our answer. The ones which did not satisfy were not included in our answer. Now let's look at this question. An organization awarded 48 medals in event A, 25 in event B, 18 in event C. If these elements went to a total of 60 men and only 5 got in all 3 events, then how many received medals in exactly 2 or 3 of these events? So first of all, this is a question of Venn diagram. What we'll do is we'll draw our 3 sets. These are our 3 sets. Let me consider this to be A. This is my B, this is my C. This is the portion which is intersection of all the 3 events. So what have they told us? That 5 men got medals in all 3 events. That means 5 men are going to be here. So in total, there were 48 medals in A. In total, there were 25 medals in B and 18 in C. Now let's say if in this portion we had A number of medals, this we had B, let's say here we had B, here we had C, here we had D, E and F. So D represents the number of medals which were in A as well as B. F represents the number of medals, people who got medals in both event B and event C. For E also the same thing, the number of people who got medals in both A and event C. So from here we've gotten this. So they've told us that there were total 60 men. So total 60 medals were there. So what we can say is A plus B plus C plus D plus E plus F plus 5. This is equals to 60. This is one equation that we've gotten. The other equation is A plus D plus E plus 5. This is equals to 48. So this 48 here includes all the medals that were received from event A. Now for B, this would become B plus D plus F plus 5. This is equals to 25. Similarly for C also we will write down our equation. This would become C plus E plus F plus 5. This is equals to 18. Now what they've asked us to find out, how many received medals in exactly 2 of 3 events. So D received in exactly 2 of 3 events, F received and E received. So basically we need to find out D plus E plus F. Again, this does not include 5 because they have told us exactly 2 of 3 events. That means we cannot include the one which won in all 3 events. So from here we need to find out D plus E plus F. So let us consider this to be our main equation because here we have D plus E plus F. What we'll do is we'll substitute A, B and C from all these 3 equations in this main equation and find out our answer. Because if I substitute A, what is it going to come out to be? It is going to come out to be in terms of D and E. D and E is in our question that was asked. For B, D and F. D and F is also in our question. For C, E and F. E and F is also in our question. So from here, what I'll do is I'll simply start replacing the values of A, B, C in the main equation. So what would A become? A would become 43 minus D minus E plus, this is my A, or let me remove the bracket simply so that it becomes easier. I'll replace the value of B. B would become 25 minus 5 minus D minus F. So this would become 20 minus D minus F plus, replace the value of C. It would become 13 minus E minus F. This plus D plus E plus F plus 5 is equals to 60. Now let us simply just solve this question to find out a D plus E plus F. So first of all, this D can cancel out one of the D's. F, E and F. E and F can also get cancelled out. So from here what do we get? 43 plus 20 makes it 63 63 plus 13, we get 76. 76 plus 5, we get 81. So 81 minus D minus E minus F is equals to 60. So if we take all the variables to the one side, we are going to get D plus E plus F. This is equals to 81 minus 60, 21. So this is what exactly we needed to find out. This becomes our answer. So I hope you must have understood how we solve questions related to Venn diagram. Again, it is very simple to solve such questions. You just need to use a little bit of logic. Write down whatever has been asked in the question one by one, point by point, and then you are going to find out your answer very easily.